Hello everyone. In this video we are going to talk about two different topics. One is feature extraction from categorical data using one-hot encoding, and the other one is standardizing data before doing machine learning on them, which in many cases causes the convergence to be basically better, the speed of it to be better, right? So these are some initial things on machine learning, and I said let me talk about them as well while I'm talking about all different algorithms. So what we need is pre-processing for this standardizing data, which we bring from Scikit-Learn, and then from Scikit-Learn feature extraction _ extraction, we need this guy called dict vectorizer, which is basically converting a dictionary. It's not exactly dictionary what we have, it's a list here, but converting it into, or converting words, categorical data into vectors, into numbers, so machine can understand and perform algorithms on. And from pre-processing, we also need the robust scaler for the second part with data with outliers. And so what we need here is, first we bring in this dict vectorizer, this class, and here assign it to this variable one-hot encoder. So I can use the fit_transform method of that. And what I have here is basically some variable, whatever you want to call it, cities, X, Y, doesn't matter. It's a list where we have this variable city, and this variable city can take over, let's say, 3 different values: Phoenix, LA, and Boston. And so if I want to use them as my X data for a machine learning, right, whether supervised or unsupervised, you know, computer cannot work with Phoenix or LA. Computer understands numbers, right? At the end of the day, zeros and ones. So what we need is to convert these into numbers. And one of the methods is called one-hot encoder. Well, basically, it assigns to them, like, for example, if you know one-hot encoder, the way it does it to some numbers, right? Let me show you that. So, for example, if you have number 0 in binary with 3 bits, it's going to be 0, 0, 0, right? And then when you go to one-hot encoder, let's say it could be a similar thing, right? Now, if I go with 1, the decimal 1, in binary, it is going to be what? It's going to be 0, 0, 1. In one-hot encoder, I'm sorry, 0 is like this. The one-hot encoder for 1 is going to be like this, 0, 1, 0, and then let's say I only have 2, then 2 is going to be what? In binary, it's what? It's 0, 1, 0, right? But in one-hot encoder, it's going to be what? 1, 0, 0. So what is this one-hot encoding? It's a way of encoding your variables into some zeros and ones where only one of the numbers is 1, everything else is 0, and it's always the nth state corresponding to your variable. So if your variable is 2, then index number 2, right, if you count from right to left, not left to right, here, this location is going to be 1. If it's 1, then it's this one. If it's 0, it's the first one. And here I can add a little bit more data maybe. So let's say I go to 7, right? So here I have added them to 7, and because with number decimals of 0, 0, 0, all the way to 1, 1, 1, you can cover from 0 to 7. These are the one-hot encoding for each one of these numbers. And let me make sure there is no mistake in them. Only one of the numbers is 1, and that is exactly corresponding to your variable. So your first variable has only the first number on the right side, 1. The second one has the second from the right side, 1, and so on and so forth, okay? So only the nth position corresponds to the nth variable. That is when everything else is 0. That's one hot encoding, which here I'm going to apply to Phoenix, LA, and Boston. And since I only have 3 variables, then I'm going to basically take over these first 3 numbers, right? So let me show you that one. So this is if you want to convert words, right, for word processing and natural language processing. Here you can use that. You see here? And since I only have 3 positions, I don't need these extra 5 zeros behind each one of them because they are common and they have no value. So I can get rid of those 5 zeros and I can only show the first 3 digits on the right hand side of these, as you can see. So now, from now on, Phoenix corresponds to 001, and that's how I can process it. The other thing I wanted to talk about are standardizing data. So standardizing means we have data in general that has the same average and the same standard deviation, and what we do is we typically have them have a mean of 0 and a standard deviation of 1. So if my data has no outliers, the simplest thing you can do is you subtract the mean from the data, whatever the mean is, you subtract all of the mean of that data from all of them, right? So your new data is going to be the old data minus the average of the old data. That makes the average of the new data 0, and then if I divide those results by the standard deviation of the old data, now the standard deviation of the new data will be 1. And so you can do that either directly by simple vector operations, or you can use from the preprocessing submodule the method called .scale. And .scale does both of them at the same time. So if I pass my x data, which here you clearly can see the average is not 0, the standard deviation is not 1, and I'm going to show you what they are. If I apply that to x and call it some new x standard, then you're going to see for x standard, the mean and the standard deviation are 0 and 1 respectively, right? So let me show you that. And in many machine learning algorithms, it is important to do that, especially if you have more than one sets of data and you want to use all of them combined for machine learning. So if I have, let's say, 2 inputs, x1 and x2, and then an output y, and I want to do some regression or anything, if the mean and the standard deviation of, especially the standard deviation of x1 and x2 are different, then one of them will dominate the regression. So we want to have them both the same mean and the same standard deviation, so it's their effect is not dominated by their size. Okay, so let me show you this one. This is an important pre-processing in machine learning. So here is my original x. You see the average is 7.4, the standard deviation is 4.1. Now that I standardized it, these are my data from negative 1.5 all the way to 1.6. And you see their average is almost 0, 10 to the negative 17, and their standard deviation is almost perfectly 1. And this is because of course, numerical errors and so on. But you see now, I'm going to use this data instead of this one in my machine learning. So I use .scale from preprocessing, okay, which you bring in from your Scikit-Learn. Now, if your data does have outliers, so your data has something that is way out of the distribution, like for example here you see all of these data are very close to each other, and then I have something very smaller and very much bigger, then if you do a box plot analysis that I did in one of the previous videos, you can probably see that clearly this is there is some outliers here. So what I need to do is I pass them this time to the preprocessing .robust scaler. Okay, I need this guy. I import it from preprocessing, and the robust scaler, the way it standardized data is it subtracts the median. You know, for data with outliers, always we use median, not mean, because median is not so sensitive to the noise and outliers. And instead of dividing by standard deviation, which is affected by outliers big time, we divide it by the interquartile range, which is the 70th 5th percentile minus the what? The 25th percentile of the data. And this way, the numbers that we get are, of course, going to be what? They are going to be standardized. Now, in this case, it doesn't mean their mean and standard deviation are going to be 0 and 1 because we are dividing by some other numbers. But, and I'm going to show you that here. But this is a better standardization when you have outliers in the data. The way you go about it is here, first I need my x to be reshaped with -1 and 1. And then I apply my robust scalar dot fit. So I pass dot fit to x. And then whatever you can call that variable's name, that transformer, I use dot transform under it. So this is an object here. And then that object, I use the method dot transform from it, pass the x to it again, and this is now the x standard. Okay? So if you want to do it all in one line, after this dot fit x, you have to use dot transform x. Then you can have the standard data with the outliers. So let me show you that one as well. And now, as you can see, the mean actually, in this case, interestingly, is about 0, which is really good, but the standard deviation is not 1. And of course, we divided by interquartile range here. Okay, but before that, the data had mean of 13 and standard deviation of 6.6. Now it's 1.6, closer to 1, and mean is 0. Okay, and we could not be affected by these outlier data. So these are two methods for standardizing data with and without outliers, and this is converting categorical data, like words here, into variables, that numbers that computer can process using the dict vectorizer and using one-hot encoding that I explained here. Hopefully the video was useful to you, and I'll see you in the next lecture. Thank you.